You ever have one of those moments where you're staring at a machine and you realize it's significantly smarter than you are?
Tiger, I watch you look at your smartphone with that exact expression every single day.
Fair point. But I'm talking about the CNC. I spent 20 years training my hands to feel the grain, to hear when a router bit is screaming for mercy, and then I bought this computer-controlled beast. It's like inviting a NASA scientist into your shop who speaks a language made entirely of numbers and spite.
Is that why I found you yesterday morning just hovering over the gantry? You looked like you were trying to telepathically communicate with a slab of oak.
I was trying to figure out why my feeds and speeds felt like a polite suggestion to the machine rather than a command. It's a whole different world, Alex. Today, I want to talk about that transition. Getting into CNC routing without losing your mind, or your most expensive carbide bits.
Well, for those of us who weren't born with a chisel in our hands, the CNC is actually less intimidating than a table saw. But the jargon, feeds, speeds, toolpaths, G-code, it's a lot of vocabulary before you even make a chip.
It really is. And the numerical control part of CNC, computer numerical control, is the heart of it. It's basically just a high-speed carving motor on a set of rails that moves exactly where a computer tells it to. No more, no less. It doesn't have craftsman's intuition. If you tell it to dive 2 inches deep into a piece of Purple Heart at 80 miles an hour, it's going to try.
And that's usually when the sparks and sadness phase of the hobby begins.
Exactly. People think the C in CNC stands for cold-blooded. But look, for anyone starting out, it's just 3 axes. X is side to side, Y is front to back, and Z is the one that causes all the gray hair, the up and down.
So, if someone is sitting there with a brand new machine still in the crate, where do they actually start? Because learning G-code sounds like a weekend spent in a dark room with a textbook.
No, nobody actually writes G-code by hand anymore unless they're a masochist. It's a 3-step dance. You have CAD, which is your drawing, think Fusion 360 or Vectric. Then CAM, which is where you tell the machine how to cut that drawing. And finally, the controller, which is the box that actually talks to the motors.
Okay, let's talk about the CAM part, because that seems to be where the magic and the disasters happen. You mentioned feeds and speeds. Break that down for someone who thinks feed is what you give a dog.
This is where I paid my biggest tuition in broken cutters. Speed is how fast the bit itself is spinning, the RPM. Feed is how fast the machine is pushing that spinning bit through the wood.
So you just crank both to the max and get the job done faster, right?
If you want to turn your workshop into a smoke machine, sure. It's all about the chip load. You want the bit to actually cut a tiny flake of wood, not just rub against it. If you spin the bit at 20,000 RPM but move the machine at a snail's pace, that bit is just friction cooking the wood. You'll get burns, you'll dull your bit in 5 minutes, and it sounds like a banshee having a bad day.
So the bit needs to take a bite.
Exactly. A healthy chip carries the heat away. If you touch a finished cut and the wood is hot, you're doing it wrong. It should feel cool or maybe just a bit warm. The chips are your heat sinks. If you're just making fine flour or dust, you're essentially sanding your way through the board with a very expensive, very fast-moving stick.
Speaking of expensive sticks, let's talk bits. I see guys with these starter kits that have 50 different shapes. Do you actually need more than 3?
Honestly, most beginners could do 90% of their work with 2 bits, a 1/4 inch downcut spiral and a 60-degree V-bit for engraving.
Downcut? That sounds counterintuitive. Doesn't the sawdust need to come out?
You're sharper than a fresh Freud blade, Alex. An upcut bit pulls the chips up out of the hole, great for deep pockets so you don't clog the works. But it also pulls the wood fibers up, which leaves a raggedy edge on the top of your plywood. A downcut bit pushes the fibers down, giving you a finish so clean it looks like it was cut with a laser. The trade-off is you have to be careful with your depth because the chips get packed into the groove.
So you're basically choosing between a clean top surface and an easy life for the machine.
Welcome to the world of trade-offs. I remember a project I did early on, a big topographical map of the Appalachian Trail. I used an upcut bit because I wanted to clear chips efficiently. I spent 4 hours sanding the fuzz off the edges of every single ridge. I could have just used a downcut bit and spent those 4 hours at the pub.
Every lesson you learn seems to end with you wishing you were at the pub.
It's a recurring theme. But look, there's also the compression bit. That's the mullet of the CNC world. Upcut on the very bottom, downcut on the top. It pulls the bottom fibers up and the top fibers down.
Business on the top, party on the bottom?
Exactly, it gives you a perfect edge on both sides of a piece of plywood. But man, they're pricey. You don't want to snap one of those because you forgot to tighten your collet.
Let's talk about that. The I forgot to tighten the collet moments. What are the common rookie moves that lead to that heart stopping crunch sound?
Oh, I've got a list. First one, not zeroing your z-axis correctly. You tell the computer this is where the top of the wood is, but your bit is actually a quarter-inch lower. You hit start, and the machine tries to teleport the bit through your workpiece and into the aluminum bed.
That's the stuff of nightmares. Do you actually use one of those touch plates, or are you a piece of paper kind of guy?
I'm old school. I use the slip of paper method. You lower the bit slowly until you can't slide the paper under it anymore. It's cheap, it's reliable, and the paper doesn't care if you accidentally crush it.
What about tabs? I see people forgetting those all the time, and then their project becomes a projectile.
Ah, the CNC frisbee. If you're cutting a shape out of a board, once that final pass goes through, that shape is no longer held down by anything. The spinning bit will grab it and launch it across the shop like a clay pigeon. Tabs are just tiny bridges of wood you leave behind to keep the piece tethered. You snip them off later with a chisel.
It sounds like a lot of prep work for something that's supposed to be automated.
It's a different kind of work. You're trading physical sweat for mental labor. You're thinking 3 steps ahead. How am I holding this down? Is the bit going to hit my clamps? Did I set my lead in so the bit doesn't just plunge straight down like a jackhammer?
You mentioned toolpaths. That's another one that confuses people. Pocketing versus contouring. Is it just names for the same thing?
Not even close. A contour is just following a line, cutting out a shape. A pocket is when you want to hollow out an area, like the inside of a bowl or a tray. Then you have V carving, which is the real magic trick. It uses a pointed bit and moves it up and down as it travels to create sharp corners you literally cannot get with a round bit.
That's how you get those fancy signs with the crisp lettering.
Precisely. If you try to cut a V or an A with a straight bit, the corners will always be rounded because the bit is round. A V-carved toolpath calculates the geometry to lift the bit into the corners. It's the one thing that still makes me feel like I'm living in the future.
Is there a secret sauce for getting a good finish? Because I've seen some CNC projects that look like they were gnawed on by a beaver.
Step over. That's the secret. When the machine is cleaning out a flat area, it moves back and forth. The step over is how much the bit overlaps with the previous pass. If you set it to 50%, you're using half the bit's width. If you want it to look like glass, you set it to 8% or 10%. It takes 10 times longer, but you won't have those little ridges, the mowing the lawn lines.
So it's a patience game.
Everything in the shop is a patience game. You can either spend the time in the software getting the toolpath right, or you can spend the time with a sanding block and a sore shoulder later. I know which one I prefer, and it usually involves the one where I can drink coffee while the machine does the vibrating.
Speaking of vibrating, maintenance. These things aren't set it and forget it, are they?
Lord, no. A CNC is a giant vibration machine. Every bolt on that frame wants to shake itself loose. I have a ritual every Monday morning. I check the belt tension, I wipe the dust off the lead screws, and I make sure the gantry is still square. If your gantry is even a hair out of alignment, your circles will come out looking like eggs.
The egg-shaped circle sounds like a failed indie band.
Or a very frustrated woodworker. I spent a whole day trying to fit a round inlay into a round hole, and I nearly threw the whole machine out the bay door before I realized the left side of my machine was a millimeter ahead of the right side.
We've talked a lot about wood, but the content we're looking at today mentions soft metals and plastics too. Does the CNC router handle those the same way?
Mostly, but the stakes are higher. Wood is forgiving. If you mess up, you get smoke. If you mess up with aluminum, you get a welded mess where the metal melts onto the bit and turns it into a useless glowing club. You need chip evacuation even more there. That's where you see guys using mist coolant, a little spray of air and oil to keep things from getting cozy.
It sounds like the learning curve people talk about is really just a fear curve. Once you break that first bit and the world doesn't end, you're fine.
That's the truest thing you've said all day. The first time you hear that snap, your heart drops into your boots. But then you realize that bit costs $20, the machine is fine, and you just learned exactly what not to do next time. You're just buying wisdom in $20 increments.
So, if you had to give one meaningful takeaway for the person who's scared to hit that big green cycle start button for the first time, what is it?
Don't trust the computer. Verify it. Run your program in the air first, what we call a dry run. Set your Z0 2 inches above the wood and let the machine dance. If it looks like it's going to crash into a clamp or fly off the table, you'll see it before it costs you anything.
Air cutting. I like it. Low stakes, high confidence.
Exactly. Respect the machine, but don't be subservient to it. It's just a tool, like a hammer with a really high IQ. At the end of the day, you're still the one who decided what to build. The CNC just handles the boring parts so you can focus on the soul of the piece.
Man, you can make even a robot sound poetic.
It's the sawdust, Alex. It gets in your brain.
Well, next time, I want to hear about the time you tried to CNC a fruitcake.
We don't talk about the great fruitcake incident of 2019. The shop still smells like candied cherries.
See you next time at the Tiger Den.
Keep making chips, folks. Just make sure they're the right size.